Hello everyone, welcome back to Hype. Today we are going to solve a question named majority element. It is a very important question covering a very important algorithm. The name of the algorithm is Moore voting. We're going to use Moore voting to solve this particular question. So let's get started. First of all, we'll understand the question. Then we'll try to understand different ways of solving it. We'll get till the optimal solution. And then we'll try to understand the time and the space complexity associated with it. So watch the entire video and I hope you understand every single thing. Let's get started. Majority element 2. Given an integer array of size n, find all elements that appear more than n by 3 times. Alright. So the question is very straightforward, very simple. You are given an array and you have to find out all the elements that appear more than n by 3 times in the. So let's see one of the ways of how we can solve it. So the easiest way to solve it is using a hash map. You can store the frequency of each of the elements that occur in the array into the hash map and then find out how many of them occur more than n by 3 times and put them inside a vector and return those values. So the first approach is very simple using hash map. Okay. In this approach, what we are going to do is add frequency of each element into the hash map. Find out how many elements occur more than n by 3 times. And finally, you just return the answer. Return the suitable elements. So let's take an example and try run this particular approach. Let's take one example. So let's take this example 3, 2, 3. Okay. So the test case is 3, 2, 3. So we create a hash map. Hash map has keys and values. So first of all, we iterate the array and add the frequency of each element into the hash map. The first number we see is 3. So we put a 3 against a 1. 2. 2 is not in the hash map, so we put a 2 against a 1. Again a 3. 3 is already there, so we increment its count. Now we again go through this array and find out how many times 3 appeared in our array. So it appeared twice. So 3 upon 3 is equal to 1. 2 is greater than 1. So 3 is one of the candidates. Now, after you have done this, you reduce this value to 0. Otherwise, you'll include 3 twice. Okay, then we get to 2. 2 appeared once. 1 is not greater than 1, so we do not include a 2. Then you get to 3. The value now is 0. So you don't include the 3 into the answer array. So now it must be clear why we reduced this value after using it. Otherwise, you would have had 2 3s in our array. Okay. So this is our final answer. So the time complexity is of course O of n, and the space complexity is also O of n. Now what we are looking for is an algorithm that works with O of n time complexity and O of 1 space complexity. Let us have a look at how we can solve that question. So what we are going to do is we are going to take two candidates in this. So there is a candidate 1 and there is a candidate 2. And there is the count 1 that will count the number of times candidate 1 has appeared, and there's a count 2 that will count the number of times candidate 2 has appeared. All right. So let us take a larger example to understand this. One, it is not given over here. Let us create our own example. So let's take a longer example for this. All right. So let's say this is our example. Let's try to run what I'm going to serve. So let's try to run the algorithm now. So look at the dry run very carefully, then we'll code that in. Okay. So candidate one, currently, so we start iterating the array. Currently, count one is equal to 0 and count two is also equal to 0. That means we do not have a candidate one or a candidate two. So we make this number candidate one and increment the count to one. So we have we have seen three ones. We move to the next element. It is not equal to candidate one and count two is still 0. So we make 6 candidate 2 and increment its count to 1. Move to the next number 3. It is equal to candidate 1. So we increment its count to 2. Again we see a 3. So we increment the count to 1 to 3. Then we see a 4. Now count 1 is not equal to 0 and count 2 is again not equal to 0. That means both the candidates are set and 4 is not equal to 3 and 4 is not equal to 6. So that means it is a completely new number. What do? We subtract 1 from this count and we subtract 1 from this count. Moving forward, 5. 5 is not equal to 3, definitely. But now you observe that count 2 is 0. That means candidate 2 is not set. So what do? We change candidate 2 to 5 and we make its count equal to 1. Then we get to this 5. 5 is equal to candidate 2, so we increase its count. Again, we see a 5, we increase candidate two's count. Then we see a 3, 3 is equal to candidate 1, so we increment this count. Again a 3, increment this count. 5, 5 is equal to candidate 2, so we increment this count. And again a 5, we increment this count. So now 3 and 5 are only probable answers. These are probable answers. These are candidates for being the answer. You still have to check whether it is the answer or not. So now we iterate through this array and count how many 3s and how many 5s we have seen. If the number is greater than n by 3, we include this in the answer. Otherwise, we do not. The major important thing that you have to notice here is 3 and 5 are only candidates for being the answer. They are not necessarily the answer. If there is an answer, then it has to be 3 or 5 or 3 and 5. How many numbers can appear more than n by 3 times? So at max, two numbers can appear more than n by 3 times, or it can be a single number that appears more than n by 3 times, or they can be zero numbers that appear more than n by 3 times. So if there is an answer, it has to be between 3 and 5. Okay, so this is what we are going to do. This is what we are going to code in. This is called the Moore's voting algorithm. And the time complexity for this is O of n. The space complexity again O of 1. This is what we wanted, and this is what we have got. We're only taking 4 variables, so the space complexity stays as O of 1. Let us now have a look at how to code this particular algorithm. Okay, so first of all, we will take the variables that are required. So it is count 1, 0, count 2, 0. Then we will take candidate 1. Initially, we'll set it to int min, and we'll take a candidate 2. Initially, again, we'll set it to int min. Okay. So now we'll iterate the entire array. Now we'll take this number into a variable num. So nums of I. Now we'll check if this new number that we have seen is equal to candidate 1. Then we'll increment the value of count 1. If this number is equal to candidate 2, then we'll increase the value of count 2. if this count 1 is equal to 0, that means we do not have a candidate 1. So we'll make this new number the candidate 1. So we'll make candidate 1 equal to num, and we increase the value of 1. Otherwise, if count 2 is equal to 0, that means we do not have a candidate 2 as of now. So we will make this number candidate 2, and we will increment the count. Now, if none of this is true, number is not equal to candidate 1, number is not equal to candidate 2, and we already have a candidate 1 and candidate 2, then we will decrement the value of count 2 and the value of count 1. We will decrement both of their values. So at the end, candidate 1 and candidate 2 are two of the probable solutions. Okay, they're not definitely the answer, but they are just probable solutions. And we have to return a vector. Okay, so now what do we do? Let's take C1 to count the occurrences of candidate 1 and C2 to count the occurrences of candidate 2. We'll create a vector that we will return as the answer. Finally, we will return the vector. But before returning the vector, we'll iterate through the array once again. And if nums of I is equal to candidate 1, we increment count 1. And if nums of I is equal to candidate 2, we'll increment the value of count 2. If count 1 is greater than nums.size by 3, we include that in the vector. And similarly, we do it for count candidate 2 as well. If count 2 is greater than nums.size by 3, we include this candidate 2 into our final answer. And that's it. We are done with the code. Let's try to run this. So as you can see, we have successfully passed the visible test cases. Let's try to submit this. So we have completed all the test cases. Our answer has been accepted. I hope you guys understood everything I wanted to explain in this particular question. If there is any doubt whatsoever, please feel free to comment in the comment section down below, and I'll be more than happy to take whatever doubts you have. See you in the next video. Thank you so much for watching. Bye-bye.